Hi, I'm Atul and I'm an online maths and science tutor based in London right now.
Hi, I'm Paul and I'm an online chemistry tutor based in Burnley, Lancashire right now. So today we're going to have a look at calculating the relative atomic mass of magnesium, and we're trying to display it visually. So do the calculation visually as well as the written one, but hopefully by doing the calculation visually you'll be able to understand the written calculation. So we've got a sample of magnesium, and it contains the following stable isotopes: magnesium 24, magnesium 25, and magnesium 26. So before we come on to the calculation, we'll just have a look at these isotopes first. So Atul, I wondered if you'd be able to do the nucleus of magnesium 24.
And I've already got an empty nucleus here, which I'll fill up with the correct number of neutrons and protons. So magnesium 24, proton number 12. So another 12 neutrons gives atomic mass, relative atomic mass of 24. Okay. All right, so let's do this. So one neutron, one proton. Let's keep going. Just readjust them a bit. Okay, so that's 12 protons and 12 neutrons, giving 24 in total there.
Excellent, yeah, and that's a great representation. We can see visually we've got the protons that are red, and we've got 12 red counters, so 12 protons, and the neutrons are blue, and we've got 12 blue counters, and therefore 12 neutrons, and a total mass in the nucleus of 24 protons and neutrons. So, yeah, thanks, Atul. Could you do the same again for magnesium 25?
Great. So in order to save some time and effort, I guess I will make a copy of magnesium 24. I'll paste that here. Now I know magnesium 25 has one more neutron compared to magnesium 24. That's the only difference. So I'm going to drag that one extra neutron into the nucleus. And there's our magnesium 25.
Excellent. So we can see clearly there that isotopes just have different numbers of neutrons. The magnesium 25 having one more neutron than the magnesium 24. So could you do the same again for magnesium 26?
Great, so this time I'll make a copy of magnesium 25. Now, once again, compared to magnesium 25, magnesium 26 also has that one extra neutron. So I'm just going to drag that inside this nucleus. Let's put it there.
Excellent. So we can see now that we've got two more neutrons than protons. So 14 neutrons and 12 protons, and giving us the magnesium mass of 26 for magnesium 26. Okay, so now to go on to the calculation, we've got our magnesium isotopes, but our question said calculate the relative atomic mass. Now, we were given the percentage as of the abundance of these isotopes, and we were told we had 79% magnesium 24 isotopes. So if we had 100 of these isotopes, that would mean we would have 79 magnesium 24 isotopes. So I wondered, Atul, I know this is going to be quite tricky for you, but could you show us 79 magnesium 24 isotopes?
Okay, so quite literally 79 magnesium 24 isotopes. I'll take our magnesium 24 isotope from there, make a copy. I'll make that smaller. Can't fit them all in. It's a small magnesium 24 isotope. All I've done is resized it. And there's 2 there. Okay, so I've got 10 there. I'm going to make an array. Ten, 20, 30, 40. Okay, so that's 80 right now, but quite literally we have 79 in a sample of 100. If we had a sample of 100, we'd have. So I'll remove one of them. There you go.
Excellent. So that's our 79 magnesium 24 isotopes. So we now need 10, because it said 10% magnesium 25 isotopes.
10% magnesium 25. Make them about the same size. Okay, I'm gonna put these in a different array. That's 2. 4. Let's go for 5 and 5 with this one. There's 5 there. And I'll make a copy of that. That's our 10%, or in a sample of 100, quite literally 10. I'll do the same again with magnesium 26, 11%. That's quite literally 11 in a sample of 100. Not the same size. I'll place them slightly separately so they are visible and clearly identifiable. Double that to 10. So I'm manually creating all of these, so it's very, very clear in the most literal sense. There we go.
Excellent. So we can see that we've got 79 out of 100, 79% of magnesium 24 isotopes, 10 out of 100, 10% magnesium 25 isotopes, and 11 out of 100, 11% of magnesium 26 isotopes. Great. So, but we're asked to calculate the relative atomic mass, which is just the average mass here. So what we need to do is add up all these masses and divide by how many there are, which is 100.
Great. So all of this is 79. So 79 lots of 24, 79 multiples of 24. I'll get my calculator out. 1,896. Ten lots of 25. 250. 11 lots of 26. And that's their masses. Okay, so as you said, this is an averaging process where you take the combined mass of all of these isotopes in this sample of 100 and divide by 100 to find the average. So step one. Gives us a total of, and finally 3. Shouldn't need a calculator, but just to be on the safe side, it gives us a relative atomic mass of 24.324 magnesium.
Yeah. And to 3 significant figures, that would be 24.3, which is what we see as the relative atomic mass of magnesium in a periodic table at A level. You might not see that at GCSE level. It might just be rounded to 2 significant figures.
Yes, of course, yeah. So 24.3, so I'll do that as well with the mathematical approximate symbols. And just clarify that's 3 significant figures. Brilliant. So this is a very literal way of showing how to find the average, taking into account of all the abundances when he got a sample of 100. So that's what percent means mathematically anyway. It's per 100. And in previous videos we've done it where it's in different ratios, but it's still the same idea, but it just happens percent is per 100. So we just literally see a sample of 100 there.
Yeah, and you often get given these questions as percentages, but they're not always a whole number of percentages. So you would just go straight to the calculation if you were just given percentages.
Yes, yeah, that's a really good point, yeah, because then you won't be able to have, say this was 79.2%, we wouldn't be able to make a 0.2, so you would then do that calculation in the abstract sense, which would be 79.2, 10 point whatever, and so on and so forth, but it's the same idea. So but this, with the whole numbers, yeah, you can see it in a more literal sense. Brilliant. Yeah, it's a great demonstration of how to use and what that formula means and what it looks like literally with these specific examples. Yeah, look forward to the next one in these series of videos.
Okay, thanks, Atul. See you next time.
Cheers, Paul. Bye.